Almost every single one of us reheats leftovers at some point during the week. Most people assume that as long as the food is heated through properly, it's automatically safe to eat again. That assumption feels reasonable, but it isn't quite right. And the reason has nothing to do with taste, texture, or how the food looks on the plate. It has to do with chemistry happening at a molecular level inside that food. Chemistry you can't see, can't smell, and can't taste, but chemistry that plays out quietly, first inside your leftovers and then inside your own body. I'm Dr. William, an emergency medicine doctor based in the UK. My job puts me on the front line of what happens when ordinary daily habits quietly catch up with people, sometimes years down the line. Today, I want to walk you through 4 foods that are almost certainly sitting in your fridge right now. 4 foods that undergo real, scientifically documented chemical changes the moment you reheat them a second time. Stay with me until the end because the 4th food on this list is going to surprise you. It's one that almost every health-conscious person assumes is completely safe, and that assumption is where the problem actually starts. Why this matters. Before we go any further, I want to be clear about what we're actually discussing here. This isn't about an upset stomach after lunch, and it isn't about a one-off bout of food poisoning. What we're talking about is something slower and quieter, a gradual, cumulative buildup of compounds that researchers have linked to cellular damage over months, and more realistically, years. Cancer very rarely appears overnight. It's the endpoint of a long chain of small biological events building on each other, and some of the building blocks in that chain, things like free radicals, advanced glycation end products, and nitrosamines, don't always come from cigarette smoke or industrial pollution. Sometimes they come from something as ordinary as how a meal was stored and reheated in your own kitchen. Health authorities around the world have flagged several compounds that form during the reheating of certain foods as either confirmed or probable human carcinogens. These aren't fringe theories. They're documented reactions that happen on your stovetop or inside your microwave. And here's the part that tends to catch people off guard. The people most exposed to this risk usually aren't eating badly at all. They're eating the exact things doctors and dietitians recommend every day: lean protein, cooked vegetables, rice, and eggs. Those 4 categories are exactly what we're covering in this video. And by the end of it, you'll probably look at your leftovers a little differently. Before we get into the specific foods, let me quickly explain why I'm talking about this at all. Not to impress you, but because in a space full of health noise online, you deserve to know that what you're hearing is grounded in real research rather than guesswork. Everything in this video reflects a synthesis of peer-reviewed food science and toxicology research, the kind of material published in journals covering food chemistry and cancer biology, translated into plain language. I'm not here to sell you a supplement or a course. I'm here because prevention starts with information, and this is information that rarely makes it to the dinner table, even though it's been sitting in the scientific literature for years. A quick primer before we start. I need to give you a short but essential primer on food chemistry before we look at the 4 foods themselves. So please don't skip this part because it's the key to understanding everything that follows. When food is cooked for the first time, heat drives a set of normal, predictable, and generally harmless reactions. Proteins unfold, starches gelatinize, fats emulsify. That's just cooking. But reheating food that has already gone through those changes, particularly food that's spent hours or days in the fridge, sets off a completely different set of reactions. 3 of them matter most for what we're discussing today. First, oxidation. Fats and proteins exposed to oxygen during storage become chemically unstable. The second round of heat breaks those already damaged molecules down further into byproducts like lipid peroxides, compounds capable of interacting with and damaging DNA. Second, the Maillard reaction pushed too far. This is the same browning reaction responsible for the appealing color and flavor in a lot of cooked food. But when proteins and sugars are repeatedly exposed to high heat, They can generate advanced glycation end products, compounds associated with chronic, low-grade inflammation, one of the recognized drivers behind cancer development. Third, nitrate to nitrite conversion. Certain foods naturally high in nitrates undergo bacterial conversion while sitting in the fridge. On reheating, those nitrites can be further transformed into nitrosamines, compounds widely classified as probable or confirmed carcinogens. Three mechanisms: oxidation, glycation, nitrosamine formation. Hold on to those three terms because you'll see at least one of them show up in every food we go through. Food one, rice. Rice is the most widely eaten staple food on the planet, and reheating leftover rice is a deeply ingrained daily habit across almost every culture. The real problem, though, has very little to do with the actual act of reheating and everything to do with what happens to the rice during the time it spends in the fridge between the first cooking and the second. As cooked rice cools, it becomes a near ideal environment for a bacterium called Bacillus cereus. This isn't some rare contaminant. It's naturally present in raw rice. It survives the initial cooking process, and it can multiply quickly in rice left at room temperature or stored for too long in the fridge. When you reheat the rice, the heat kills the bacteria, but it does not destroy the heat-resistant toxins those bacteria have already produced. Those toxins survive the microwave, they survive the stovetop, and they end up in your digestive system intact. While the bacterial side of this is significant on its own, there's a separate concern that's more directly relevant to what we're covering today. Bacillus cereus produces a toxin that lab studies have shown can affect mitochondrial function inside human cells. And mitochondrial dysfunction is considered one of the early biological events that can contribute to abnormal cell transformation. On top of that, repeated heating of starch-rich foods like rice increases the formation of acrylamide, a compound produced when natural sugars react with certain amino acids under high heat, and one that's classified as a probable human carcinogen. What to do instead? Cook rice fresh whenever you reasonably can. If you do need to store it, spread it out on the shallow tray straight after cooking so it cools quickly. Get it into the fridge within an hour, eat it within 24 hours, and avoid reheating it more than once. Food 2, chicken. Here's something that tends to surprise people. Chicken is arguably the world's most recommended lean protein. Doctors, dietitians, and fitness coaches all build meals around it. And when it ends up as leftovers, almost everyone reheats it without a second thought. That's exactly where the issue begins. When animal muscle protein is exposed to high heat a second time, it undergoes a process called protein oxidation. And one consequence of that process is the formation of compounds known as heterocyclic amines, or HCAs. These aren't a fringe topic. They're among the most extensively studied compounds in dietary cancer research. Once metabolized by the liver, HCAs are converted into reactive compounds that can bind directly to DNA. And that kind of DNA interaction is one of the primary ways genetic mutations occur, particularly in tumor suppressor genes, one of the core mechanisms behind how cancer starts in the first place. Research has linked frequent consumption of well-done or reheated poultry to a measurable increase in colorectal cancer risk. The separate line of research has associated frequent consumption of reheated processed chicken with an increased risk of pancreatic cancer, one of the most aggressive cancers, with a 5-year survival rate that remains stubbornly low. The next two foods are the ones people tend to misunderstand the most. One is a food that health-conscious people take real pride in eating regularly. The other is something doctors and dietitians recommend constantly, and yet almost nobody talks about what happens to it on the second round of heat. If you're finding this kind of practical, evidence-based information useful, consider subscribing. I put out one video a week, always the same approach: real research translated into information you can actually use. No hype, no supplements to sell, just the science and what it means for your health. Food 3, spinach and other nitrate-rich greens. Spinach is one of the most celebrated vegetables in nutrition, and for good reason. It's rich in iron, folate, magnesium, and a wide range of antioxidants. Doctors and dietitians consistently recommend eating more of it, and they're right to, when it's eaten fresh or cooked once and eaten straight away. The problem starts once spinach is stored and then reheated. Spinach, along with chard, beets, celery, and lettuce, is among the richest natural dietary sources of nitrates. In their original form, those nitrates are genuinely beneficial, supporting cardiovascular health and healthy blood pressure. But once cooked spinach sits in the fridge, naturally occurring bacteria on the leaf surface begin converting those nitrates into nitrites, the same basic chemical conversion involved in cured meats. Part of the reason processed meat carries the classification it does. When spinach that's been refrigerated for a day or more is reheated, you're applying heat to a vegetable that's already undergone substantial nitrate to nitrite conversion. And under that heat, the nitrites can react with amino acids to form nitrosamines, among the most potent dietary carcinogens identified so far. Research consistently links high nitrosamine exposure with increased risk of stomach, esophageal, and colorectal cancers. The irony here is hard to miss. One of the healthiest vegetables available can become a source of harmful compounds simply because of a storage and reheating habit practiced weekly by health-conscious people everywhere. What to do instead? Cook leafy greens fresh whenever possible and eat them right after cooking. If there are leftovers, eat them cold within a few hours rather than reheating. Avoid storing cooked spinach specifically with the intention of warming it up later. Food 4, eggs. I told you the fourth food would surprise you. Here it is, eggs. Nutritionally, eggs are about as complete as food gets. They contain all 9 essential amino acids. They're a strong source of choline for brain function. They provide selenium for antioxidant defense, and they contain lutein and zeaxanthin, both linked to eye and cellular health. By almost any standard, eggs are one of the healthiest things you can eat. But reheating cooked eggs, particularly scrambled eggs or hard-boiled eggs, creates a specific chemical issue that rarely gets discussed. Eggs are roughly 13% fat, most of it concentrated in the yolk. During the first cooking, that fat undergoes an initial, entirely normal stage of oxidation. But when a cooked egg is refrigerated and then reheated at high temperature, those already oxidized fats undergo a second, faster round of oxidation, producing byproducts including oxysterols. Reviews in the scientific literature describe oxysterols as having pro-inflammatory effects and, more importantly for this discussion, genotoxic effects, meaning they're capable of damaging the genetic material inside cells. Genotoxic compounds are considered potential carcinogens precisely because they can cause DNA strand breaks and mutations, the kind of damage that can start the chain of events leading toward cancer. There's a second layer to this. When cooked egg proteins are exposed to high heat again, especially in a microwave, they undergo further denaturation and can form abnormal cross-links that are harder to digest. Some research also suggests the sulfur-containing amino acids in eggs can degrade with repeated heating, and the degradation products may contribute to oxidative stress in the lining of the digestive tract, one of the mechanisms proposed in the development of colorectal cancer, one of the most common cancers worldwide. What to do instead? Eat eggs shortly after they're cooked. If you're preparing them ahead of time, keep hard-boiled eggs in their shells and eat them cold. Avoid reheating scrambled eggs or omelets in the microwave, and if you absolutely need to warm an egg dish, use gentle indirect heat like a warm water bath rather than high direct heat. An honest moment. I want to be honest about something. When I first went through the research on reheated food, the nitrosamine formation, the heterocyclic amines, the oxysterols, my first reaction wasn't alarm. It was frustration. This information isn't hidden. It's sitting in peer-reviewed journals and public health guidance. It just almost never makes it to the dinner table in a form that's clear and practical enough for people to actually use. Millions of people make decisions about reheating food every single day, not because they're careless, but because nobody ever laid this information out for them clearly. Kids eat reheated rice and eggs in packed lunches 5 days a week. Older adults living alone reheat leftover chicken because it's simple and convenient. People doing meal prep for the gym eat the same reheated high protein containers every day, convinced they're optimizing their health, unaware that the chemical makeup of that food has shifted since it was first cooked. None of these people are doing anything wrong. They just didn't have the information. Now you do, and that's really the whole point of this channel. Closing the gap between what the research already shows and what actually reaches people in their kitchens. Wrap up. So let's bring it all together. 4 foods, 4 different biological mechanisms, one simple takeaway. Rice. Reheating can reactivate heat-stable bacterial toxins and increase acrylamide formation. Mechanism. Bacterial toxin activity and acrylamide formation. Potential link. Mitochondrial dysfunction and exposure to a probable carcinogen. Chicken, reheating at high heat promotes heterocyclic amine formation through protein oxidation alongside lipid oxidation byproducts. Mechanism, protein and lipid oxidation. Potential link, direct DNA interaction and increased colorectal and pancreatic cancer risk. Spinach and nitrate-rich greens. Storage followed by reheating drives nitrate to nitrite to nitrosamine conversion. Mechanism, nitrosamine formation. Potential link, increased risk of stomach, esophageal, and colorectal cancers. Eggs, reheating accelerates lipid oxidation and produces oxysterols alongside further protein denaturation. Mechanism, lipid oxidation and protein cross-linking. Potential link, genotoxic effects and oxidative stress in the digestive tract. None of this is about being afraid of your fridge. It's about making informed choices with food you already trust, understanding that how you store and reheat a meal matters almost as much as what's in it in the first place. If this was useful,